So let me start with what actually happened. It's August 15th, 1977. There's this radio telescope in Ohio called the Big Ear. It's not one of those fancy rotating dishes you see in the movies. No, it's a flat reflector, and it just sits there while the Earth rotates underneath it. Simple, clever design. It scans the sky systematically, and each spot in the sky gets exactly 72 seconds of observation time, just long enough to potentially catch something interesting. Now, the people running this telescope are looking for signals from extraterrestrial intelligence. That's what SETI means, Search for Extraterrestrial Intelligence. And they've been doing this continuously since 1973. They're methodically scanning the sky, and they have no idea that they're about to find the most famous signal in the entire history of the search for aliens. A few days after August 15th, a researcher named Jerry Ehman is reviewing the computer printouts from the observations. And you have to understand, these were literally printouts on paper. Numbers and letters representing the strength of radio signals at different frequencies. He's looking through data and he sees something. The signal is 30 times stronger than the background noise. It's at exactly 1420 megahertz, the frequency of neutral hydrogen, the hydrogen line. This is special because it's what radio astronomers thought an alien civilization would use to communicate. It's called the water hole, right where hydrogen and water frequencies meet, quiet part of the spectrum where any civilization would think to look. Jerry Ehman is so startled by what he sees that he circles the signal on the printout and writes "wow" in red pen next to it. Just like that. That's how one of the greatest mysteries in astronomy gets its name. Now here's the thing, and this is important for understanding how science actually works. Jerry has no way to follow up immediately. The signal is gone. It lasted 72 seconds, and it doesn't repeat. That's it. The telescope has moved on to scan the next part of the sky. There's no computer system to alert them in real time, no ability to point the telescope back at that spot and say, wait, hold on, let's look again. It was a different era. They have to look back at the data, realize something extraordinary happened, and then they have to try to figure out what to do next. So they search for it again. They look at the same region of sky over and over. Nothing. They wait for it to repeat, thinking, if it's really an alien civilization trying to communicate, maybe they'll send the signal again, like a cosmic, hello, is anybody there? But there's nothing. Years go by. Decades go by. Nothing. This creates a real problem, you see, because on one hand, the signal fits everything you'd want in a message from alien intelligence. It's the right frequency, it's powerful, it's narrowband, meaning it's concentrated in a specific frequency, which is exactly what you'd expect from an intentional transmission. But on the other hand, it never comes back. And if you're trying to communicate with someone, wouldn't you keep sending the signal? Wouldn't you try more than once? So for about 50 years, this signal sits there in the back of everyone's mind. Is it aliens? Was it a fluke? Was it interference from Earth? Nobody knows. And the interesting part is that people become emotionally attached to this signal. It represents a possibility that we're not alone, that there are other civilizations out there. And that's a beautiful thought, but it's a thought that makes it hard to think clearly. You see, here's what I always worry about in science. We have a tendency to fall in love with our ideas. We want them to be true. And when we want something to be true, we don't examine the evidence as carefully as we should. We start with the answer we want and work backwards. Let me tell you about how a scientist should think about this. You should say, what's the most likely explanation? Not what you want to be true, but what's actually most likely given what we know about the universe. And what do we know? We know that the universe is full of things we don't understand yet. We know that there are strange radio sources out there, pulsars, quasars, all sorts of things that seemed impossible before we discovered them. We know that electromagnetic radiation comes in many forms and from many sources. Now here's where it gets interesting. A scientist named Abel Mendez and his colleagues decided to look at old data from the Arecibo Observatory, a famous radio telescope that's now defunct. They're not looking for the wow signal specifically. They're just analyzing archived data, looking for patterns. And what do they find? They find smaller versions of the wow signal. Not as strong, not quite the same, but similar enough to be interesting. This is crucial. This is where the detective work of science actually gets good. These weaker signals come from regions of space that contain cold hydrogen clouds, atomic hydrogen scattered around the galaxy. This isn't mysterious. Radio astronomers have known about hydrogen clouds for decades. In fact, back when radio astronomy was young, they used hydrogen clouds to map out the spiral structure of the entire Milky Way. It's ordinary astronomy. But here's the puzzle. These hydrogen clouds by themselves are too dim to produce the wow signal. They don't emit enough radio energy. So what if something boosted them? What if something gave them energy and made them brighten up temporarily? Enter the magnetar. Now, a magnetar is something truly strange. It's a kind of neutron star that's about 20 kilometers across, but so dense that a teaspoon of its material would weigh as much as a mountain, and it has an incredibly strong magnetic field. When a magnetar flares up, it releases enormous amounts of energy. Imagine something so powerful that it can make a radio burst that travels billions of miles through space. Here's the hypothesis. A magnetar flares. That flare sends out a beam of concentrated microwave energy, what physicists call a maser, which is like a laser but with microwaves. This beam of energy passes through a cold hydrogen cloud, and when it hits the cloud for a moment, the cloud glows. It emits radio waves at the hydrogen frequency, bright enough to be detected thousands of light years away, bright enough to appear on Jerry Ehman's printout as something extraordinary. And then, just as quickly, the flare ends. The boost to the hydrogen cloud ends. The signal vanishes. A 72-second cosmic event, never to repeat from that exact location, because the source has moved on through space or burned itself out, or whatever magnetars do. Now, I have to tell you something about this explanation. It's a good explanation. It makes sense, but, and this is important, it's still somewhat speculative. The physicists themselves say so. The exact conditions that would need to align to create this effect are delicate and specific. It's not an everyday thing, but then again, neither is the wow signal. If the signal is real, and it does seem to be real, the data shows it was there, then something rare and unusual happened. That's how rare events work. What I find remarkable is how this story teaches us about how science actually works versus how we imagine it works. In the movies, an alien signal arrives, and it's dramatic. Alarms go off. Scientists are notified immediately. Telescopes swivel around. We get confirmation within hours or days. But real science isn't like that, especially not in 1977. Real science is patient. It's methodical. It's about collecting data and looking at the data again later with fresh eyes. And here's the really interesting part. The people at SETI, the actual scientists who spend their lives looking for alien signals, they're not devastated by this explanation. They're actually okay with it, because here's why. If the signal was the magnetar-hydrogen cloud effect, then they now know about a phenomenon they didn't know about before. They understand something new about the universe, and that's genuinely interesting. And it's also useful because now if they find another similar signal, they can say, oh, this might be a hydrogen maser event, not an alien signal. But here's what bothers me about the whole thing, and I think this is the deeper lesson. Almost all of us, we wanted the wow signal to be aliens. Even the people who were skeptical, some part of them was hoping, and that's human. We're alone on this planet as far as we know. The idea that there's someone else out there, another civilization, another intelligence trying to reach across the darkness, it's profound. It would change everything. It would answer one of the biggest questions we can ask. But wanting something to be true isn't the same as it being true. And a good scientist has to learn to separate those two things. The fact that you would prefer the universe to contain alien intelligence doesn't make it more likely that it does. The facts don't care what you prefer. Now, I'm not saying it's impossible that the wow signal was from aliens. I'm just saying we don't have evidence for that, and we have to be honest about what we know and what we don't know. Here's another thing I find fascinating. We live in an age now where we have much better technology. If a signal like that arrived today, we wouldn't have to wait days to see it. Computers would flag it in real time. We could point our telescopes at the source immediately. We could make multiple observations. We could narrow down the source location. Modern radio astronomy is far more sophisticated than it was in 1977. And ironically, as our instruments have gotten better, we've found fewer mysterious signals. The aliens, Seth Shostak joked, must have known we were getting better equipment, but that's just a joke hiding a truth. Most of those mysterious one-off signals in the early days of SETI weren't aliens. They were probably instrumental artifacts, natural phenomena we didn't understand yet, or in some cases just noise that happened to look interesting. The thing that kills me is that the wow signal probably wouldn't have become famous if Jerry Ehman hadn't written wow on that printout. If he had written something boring like Anomaly 247, or if he had just filed it away without a comment, would anyone care about it now? Would it have become this cultural phenomenon? I doubt it. But that little wow caught people's imagination. It made the signal human. It told a story. And that's actually a really important lesson about science and how discoveries work. The most dramatic thing in science isn't always the most important thing. But the thing that captures people's imagination is the thing that gets attention, that gets resources, that gets other scientists interested. That's not necessarily bad, but you have to be aware of it. Now, what does all this mean for the question of whether we're alone? Does the fact that the wow signal probably wasn't aliens mean that there are no aliens out there? Not at all. The universe is incomprehensibly large. There are billions of galaxies, each with billions of stars. The idea that Earth is the only place where intelligent life has emerged seems statistically unlikely, but there's a problem called the Fermi paradox. If intelligent life is out there, where is everybody? Why haven't we found any signals? Why haven't they reached us? And these are genuinely hard questions. Some people have suggested that intelligent life is actually quite rare. Maybe the conditions needed to evolve intelligence are really specific and unusual. Maybe we are something rare, something special in the universe. There's a whole book about this idea called Rare Earth, and it makes some compelling arguments. Others suggest that maybe intelligent civilizations don't last very long. Maybe they tend to destroy themselves, or maybe they don't broadcast signals at all. Maybe they have better ways of communicating that we wouldn't recognize. There's also the possibility that we're looking in the wrong places, or listening for the wrong kinds of signals, or that we don't have sensitive enough instruments yet. The universe is huge, and we're still very much at the beginning of our search. But you know what I think is healthy? I think it's healthy to look for signals. I think it's healthy to wonder if there's intelligent life out there. But I also think it's healthy to be skeptical, to say, show me the evidence, and let's make sure we're interpreting the evidence correctly. And let's not fall in love with our own ideas so much that we can't see what's really there. The wow signal tells us something important about ourselves. It tells us that we want to believe. It tells us that the question of whether we're alone matters deeply to us, and that's beautiful. But it also tells us that we have to be careful. We have to think clearly. We have to distinguish between what we know, what we can reasonably infer, and what we're just hoping might be true. So here's where things stand now, as far as I can tell. The most likely explanation for the wow signal is that it was a natural astrophysical event, probably involving a magnetar flare and a hydrogen cloud, though the details are still being worked out. This is a fascinating explanation. It tells us about processes in the universe that are genuinely interesting and worth studying. But it's not the explanation we were hoping for, and that's okay. Science is full of moments like this, where we hope for one thing and find something else instead. Usually the thing we find is interesting in its own way. Sometimes it's even more interesting than what we were hoping for once we get past the disappointment. What I love about the wow signal story, even after all these years, even now that we probably know what it actually was, is that it shows us how science works in real time. It shows us how a mystery persists. It shows us how old data can be re-examined with new tools and new perspectives. It shows us how a scientist can work on something for decades because it's interesting, not because they're chasing aliens. And maybe that's the real lesson here. The search for extraterrestrial intelligence isn't just about finding aliens. It's about understanding the universe better. Every signal we analyze, every phenomenon we investigate, every false alarm we resolve, all of it teaches us something. All of it expands our knowledge of what the cosmos is actually like. The universe is a lot weirder and more complex and more interesting than our simple stories about it. And I think that's a much better story than aliens sending us a message, don't you think? So that's the wow signal. That's what we know about it and how we think it probably happened. It's a reminder to stay curious, to look at the evidence carefully, and to not let what we want to be true get in the way of what's actually true. And it's a reminder that the universe, even without aliens, is filled with mysteries worth investigating.